So when you're balancing equations, sometimes you'll just balance elements, like in this combustion reaction where there are no polyatomic ions. And so in doing that, you want to avoid balancing certain elements and later polyatomic ions until the very end. You see oxygen here, it's present in two products. That means that if we balance it at the beginning, perhaps by changing some number as our coefficient here, then later we'll be unbalancing the oxygen by trying to balance carbon and hydrogen. And so we'll save that till the very end. And so let's balance, say, carbon. Okay, so let's see how many of each thing we have. We have 4 carbons here, we have 10 hydrogens, and 2 oxygens here. 1 carbon, 2 hydrogens, 3 oxygens here. Okay, so let's go ahead and balance carbon. We have 4 on the left, we have 1 on the right, so we need to change our, not subscript, but coefficient in front of the entire compound, and so now we have 4 carbons here. But you know, this also changes the number of oxygens. Now, instead of having 3 oxygens on the side, we have 4 times 2, we have 8, plus 1, we have 9 oxygens on the right. So carbon is balanced. Now let's balance hydrogen, not oxygen, until the very end. And so we have 10 hydrogens on the left, we have 2 on the right, so we'll put 5 in front of water. So now we have 5 times 2, we have 10 hydrogens on the right. This also changes the number of oxygens. We have 4 times 2, we have 8 oxygens here, plus 5 oxygens here, so now we have 13 oxygens. So everything is balanced but oxygen, so now we'll balance oxygen. Now, you are going to have a difficult time because you have an even number of oxygens here and an odd number of oxygens here. And so this is kind of tricky when you're dealing with O2, but you are allowed this special privilege when balancing combustion reactions. You can write fractions, just in this case. So here we have, let's see, if we have 13 over 2 times 2, we have 13 oxygens on the left, which is the proper number of oxygens. We've properly balanced this equation. All right, moving on to the next problem, balancing a reaction which includes polyatomic ions. So let's keep a track of how much we have. We have calcium 1 here, we have 2 nitrates here, 3 sodium, 1 phosphate. We have 1 sodium, 1 nitrate, 3 calcium, 2 phosphates. So what would you like to balance first? It seems everything can be balanced. How about we just randomly choose calcium? All right, so we have 1 calcium on the left, we have 3 on the right, so we need to change the number of calciums here. We'll put a 3 in front of the entire compound, not changing our actual compound, not changing the formula, not the subscript for the coefficient. So now we have 3 calciums, but this also changes the number of nitrates. 3 times 2, we have 6 nitrates here. Now let's balance nitrate here. We have 1 nitrate here, but we would like to have 6, so we'll put a 6 in front there, 6. Which also will change the number of sodiums. Now we have 6 sodiums here. Okay, so we can balance sodium here. We have 6 on the right, we have 2 on the left, so we'll put a 2 here, so then we have 6 sodiums now. This changes the number of phosphates. Now we have 2 phosphates, and we have 2 phosphates on the right, so we're properly balanced in all places. Just double checking, 3, 3, 6, 6, 6, 6, 2, 2. Yes, it's important to kind of keep track at the very end to check your answer. All right, thanks for watching, guys.